So recipes are configuration files that describe resources and their desired state, here in green on the right. They install and configure software components. They manage files, deploy applications, and depend on other recipes. Let's have a look at an example recipe. The recipe is going to install and start Next Generation Engine. It uses an existing recipe, apt, to take care of the package management. The first line in this recipe is include recipe apt. This apt recipe will have the commands to install packages on our system. Package Next Generation Engine do action install is going to do the actual installation. To start a service, the recipe contains service Next Generation Engine do action enable and start. Recipes are stored in cookbooks, shown in amber on the right. Cookbooks contain recipes, templates, files, custom resources, and so on. They provide code reuse and modularity. Cookbooks can also be shared and downloaded from a marketplace. A lot of cookbooks are available for popular software. Right now there are a lot more cookbooks available than Ansible playbooks, and some of them are really high quality. You can even create cookbooks that depend on existing cookbooks so that you can customize existing cookbooks. Another functionality is search. You can easily search for nodes with certain roles, because Chef is keeping data of all the nodes in its central database. You can find topology data like IP addresses, hostname, and fully qualified domain names. Chef server all keeps this information, and you can query it. Another concept is configuration drift. Configuration drift happens when your infrastructure requirements change, and the configuration of a server falls out of policy. You will then need to model the new requirements in your Chef configuration files and send them to the Chef server. Chef client will pick up those changes, and the new policies are enforced. On the right, you can see the flow of the configuration drift. Node 1, the purple one under Chef server, experiences configuration drift. Then, Chef client runs to pick up the changes, and Node 1 has its new policies enforced.